Friends, today we are going to discuss a very important topic that is called the turbine operation and maintenance. You know, the turbine is the heart of an industry. So, any damage to this equipment s- it cause a huge sabotage or cause a huge shutdown to the plant, and it will take minimum uh, to rectify the problem, minimum at least in 3 weeks or 4 weeks of time. So huge production loss, and that is not at all acceptable. So that's why we have to keep the turbine running, and we have to always monitor its health, its all monitor its all parameters on continuous basis, both in field as well as on the DCS and local panels, so that if anything abnormal notice during this period, we can take the shutdown, uh, plant shutdown, and do this rectification job as quick as possible. So during the regular health checking, health monitoring. Normally we are the daily we are going to check uh, the how we will checking it by we look into the turbine, listening the sound, hear the sound, and feel by feeling of the train and auxiliaries, all the auxiliaries, say EOP, manual pump, turbine bearing, sound, etc. We have to every time, periodically, 1 hour interval, we have to operator has to go and feel it and see it and record it in a logbook. Observe and record the pressure, temperature of the gauges, the steam temperature, pressure, water temperature, pressure, etc., expansion, bearing vibration, etc., to as well as the so local panel as well as the DCS, and ensure that everything is normal. Observe oil flow from the bearing, oil flow glass. There is every return line from the turbine bearing. There is a flow indicator is there. From here you can see the whether flow water oil is coming or not, and there is temperature mounted is all mounted on this flow indicators also. So you can measure the temperature also. You can see the temperature also. Observe that the flow from the overhead tank, that maybe if there is any power failure is there turbine, and AOP, UOP, and do not start, then at least go over through overhead tank, coastal down time, as well as the minimum of 45 minutes or 50 minutes while flow should be there in the between the bearing, so it will not bearing and casing will not touch each other, and there is no bow take place. All the protection is in line, not defected. All bearing RTD are in good condition, and ensure that all the standby pumps like condenser, etc. pump, AOP, UOP are in auto mode. If any one thing is not working, automatically other one is standby one is take place coming in line. So before going to after doing one major overhauling, we have to do the start the turbine to see whether it is the major hauling done, whether it is okay or not. But during the starting, we have to take all these parameters. We have to be very careful, because we know the turbine. There is a starting curve is there, and there is a lot of critical speeds are also there. So during starting, we have to be very careful. Uh, Heating is very important, so that both turbine and casing, turbine rotor and casing expand simultaneously, equally, so that the axial gap we have maintained between stator blade and rotor blade remains same. Mm. And we can measure the casing expansion, we can measure the rotor expansion also when the recorder are there. So by seeing this, we can very well judge that yes, turbine is uniformly heated. We have to heat the turbine first. Uh, startup startup lines, heating lines are there. Um, so we have to bend the turbine inlet line, extractor lines, heatings, and then we have to slowly start the turbine. and we have to keep the bearing gear online, so that first before starting bearing the turbine should be on the bearing gear. And first you see the starting curve, cold starting stop, starting device, starting the startup curve. So first 10 minutes we have to keep the RPM very slow, that is around 500 degrees centigrade, 500 degree RPM, 500 RPM, and see whether any touching there or not, and bearing abnormal temperature there or not. And then gradually increase the temperature to 1000 degrees centigrade, and keeping there for soaking for another 20 to 25 minutes, and see the expansion and of that casing and turbine and oil temperature also. Then again you increase the increase the RPM up to 3500 degrees centigrade. That is, different turbine have different startup curves, cold and hot startup. Uh, then you have to hold there for some time. And suppose in particular case, you see from 300, 500, to 300, 3500 to 4200, there is a critical speed is there. If you keep the turbine running in this RPM, then what will happen? Turbine will, vibration will be tremendously increased, and turbine will bow, permanently bow. So you have to very quickly shift this turbine, this RPM very quickly, to open this throttle valve cutting device very quickly, so that you can very quickly pass away the critical speed. Then again, when you are passing the critical speed, then again you gradually increase the RPM up to the rated RPM, and keep it there, and see whether your AOP, auxiliary pump, which was running, and MOP has taken over or not. Once the MOP take over, you have to close the auxiliary oil pump and keep its valve open in case of emergency standby, in case of standby, and then gradually and see whether governor has taken over or not, etc. So, and keep the turbine running at that temperature, at that RPM, for at least for 15 minutes, to see all the parameters, everything, turbine governing system function, all the expansion, etc. And then you can load the turbine with, maybe with the generator, maybe with the proper case compressor, etc. So this is the cold startup. Why you are doing this? So taking so much time for cold startup? Because when you are introducing the cold steam, when you are introducing the steam into the turbine rotor, the steam will pass through the blades, and once it pass through the blades, turbine is rotating, so it will, the tendency is there, the turbine rotor will expand, quickly get the temperature. While casing is stand still, there is a guide blade carrier, then casing. So casing will take, to get this same temperature, casing will take some time. So there will be a temperature difference in the turbine as well as the casing. So due to the temperature difference, turbine rotor will expand more, turbine casing will not expand so much, not expand not this much. So there is a, whatever axial gap we are maintaining in while assembly the turbine with the casing, there they did may get disturbed, and turbine casing may, turbine rotor may touch the turbine casing. So the rubbing mark and high vibration will be there. So in the big turbine, what we have done, because it will take at least more at least 1 and 2 hours time, 1 hour, more than 1 hour time to get the casing temperature in same with the casing. So what we are doing, we are introducing in some steam in the hollow section of the casing, so that casing will get the, will come in contact with the directly steam, and then it will also expand with the similar way as that of rotor. So they are equal clearances. Differential expansion will remain same. So there should not be any chances for any touching. Similarly, hot startup is as the first turbine, suppose the turbine is running, due to some reason, you have to stop the turbine for 2 minutes, or downstream there is some problem, so you want to keep this turbine, so you cannot keep the turbine running, so you will stop the turbine. But yeah, we know when you stop the turbine, both casing as well as the turbine are in hot condition. So when you start after half an hour or 1 hour, you need not maintain the so much long time. It's like not a long time of 70 minutes or 80 minutes. You can restart it within 40 minutes. You can go and you can load your downstream driven machine with turbine. So there also you have to maintain the initial startup, then 500, then again increase the temperature, RPM by 1000 degrees centigrade, hold there for 10 minutes, then again increase the RPM, hold there for 5 minutes, and then hold there for 2 3 minutes, and then gradually quickly pass the critical speed, and then again go to the rated speed within 15 minutes, and do all the checking, parameter checking, and then you can load the turbine with downstream improvement. So there should not have any problem, because during a hot startup, both rotor and casing are in hot condition, so no question of the axial gap differences. So normally we are doing overhauling of the turbine. There are three types of turbine overhauling we are doing. One is called minor overhauling, another one is called intermediate overhauling, another one is called major overhauling. Minor overhauling, when you do the some major overhauling of the turbine and then start. So the first turbine, suppose you are commissioning the turbine, then minor overhauling come at 15,000 operating hours. Means around 7,500 if we see the per hour per year operating hours, then around 2 years, approximately 2 years, you have to take the minor overhauling. In the minor overhauling, what we are doing? We are doing the bearing inspection, coupling alignment checking, and visual inspection of all gearbox, and servicing of hydraulic control systems, means your servo motor and etc. Overhauling of governing protection device, safety system if required. This is the job what we are doing during the main minor overhauling. It will take hardly 3 to 4 hours after cooling down the turbine, and then intermediate major overhauling after when we start after minor overhauling, we start the turbine, and after 25,000 operating hours, that is around 5 years, around 5 years, you have to do the stop the turbine for intermediate inspection. Then intermediate inspection, we have to do all the job of minor overhauling, and plus radial run out check of the rotor, whether any run out had increased or not, axial displacement check of the rotor with the with thrust bearing or without thrust bearing, outer casing centering, because you need not require to open the casing. There is always a protocol reading is there. Outer casing for rotor, you mounted the dial gauge on the rotor shaft and do the put the plunger on the rotor casing machine surface, and do to check the reading. If the readings are matching with the protocol reading, that means it is okay. Otherwise, minor adjustment you can do by there is a threaded cap and bush up there that I have already explained. You can slightly up and down the turbine rotor with respect to casing, and axial thrust also by rotor thrust bearing by moving the front bearing housing through the tie rods. You can make it the bring the protocol reading, and then after intermediate overhauling, you have to do the major overhauling that will take place 40,000 operating hours. That is around 8 to 10 years. There in the major overhauling, what we are going to do, we are going to remove the rotor from the casing, clean the rotor with grid blasting, uh, thorough inspection of all internal clearance, inspect all guide blade carrier, rotor blades, etc. Do the balancing also, check the balancing also. Internal clearance, do the centering, remove the bearing pedestals, see for any grooving there underneath the spherical washers or not. If grooving is there, then you have to do the machining, remove the groove, and then again put the rotor bearing housing back into position. We keep the rotor, do the centering, and then do the alignment, cleaning all the hydraulic components. Oil replacement is very important. That during major overhauling, whatever condition may be the your oil, you have to replace the complete oil. The capacity may be very high, but you have to replace the complete oil of the turbine of the lower system, and then this is the jobs involved in major overhauling. How do you calculate the operating hours? There is a formula is there. TE is the effective operating hours. That is TA into NS into TS. What is a TE? Effective TE, your operating hours. Effective. NS is the number of start and stops. NS is the number of starts and how many times you have starts and stop the turbine. And TA is the actual operating hours. When running the turbine, how much continuously it was running. That is called actual operating hour. And TS is the startup time. TS is the startup time. Usually we take 30 hours for every in a startup time. You have to multiply it with the number of start up and stop with 30. So TE is equal to TA NS into TS. So T is suppose your NS number of start and stops, number of starts and stops is 60 per year, per year. Then and TA is the actual operating hours, that is 7200. Then TS is the startup time, we can usually take 30. So TE, how much operating hours will be? 7200. TA is the actual operating hours. I have considered 300 days it has run. 300 into 24, that is 7200, plus 60 number of starts and stops of the turbine into 30, that will equal to, that will be around 9,000 hours per year. If the same thing happen in the next year, so your total hours will be 18,000 for 2 years. But you need to do the minor overhauling at 15,000. So you need not wait up to 2 years. You can do the minor overhauling in 1.5 years. Now that is the importance of operating hours. How many stops and starts and you are doing with the turbine. That is very important. You have to keep in record the how many times you have stopped the turbine, how many times you have start the turbine, and that and actual timing uh, times is running. If you add that, add this, you'll get the actual operating hours. And then according to your time, 15,000, 25,000, and 40,000, you have to go for minor, major, intermediate, and major overhauling. If you follow these routines, your turbine will, there should not have any problem, because every day we are monitoring all the parameters and compare it and check it with previous reading, and we can come to know what is the problem, is there or not the turbine or not. Friends, I think I have clear your doubts, your everything, when you are going to take that minor overhauling of the turbine. What is the activities that need to be checked by the field operator daily, and daily, and the importance of the operating hours. If you have any more question, you can ask me directly in the mobile number or my mail ID. Uh, I think if you go through the slides, your all concept will be clear, and you'll be able to answer in the interview board.